My name is Jonathan Hicks. We're doing Bodmas with Algebra. Now, if you haven't seen the What is Algebra sort of intro video, go and watch that one first before you come here. And you also need to be familiar with Bodmas, just the normal Bodmas with numbers. So go and watch that video if you're not sure about that. But assuming you're happy with those two things, let me just give you a quick reminder of what Bodmas is and how it works with normal numbers. So each of the letters here stands for something, and it tells you the order in which you're supposed to do things. So the B is brackets. If you've got any brackets, you work those out first. The O stands for other. Now this includes a whole variety of things. Most of the time though, the thing you need to worry about is powers. So squaring, cubing, square rooting, that would all take place here. Then you get your division, multiplication, and your addition and subtraction. As I say, watch the Bodmas video if you want the details of that. Now, in algebra, you might be wondering why I'm doing a separate video for Bodmas and algebra, because in theory it's exactly the same. Remember, in algebra, any letter is actually a number. It just represents an unknown number that we haven't figured out yet. So anything you can do to numbers, like dividing and multiplying, addition and subtraction, you can do to letters as well. But the important difference here with algebra is that whereas with numbers you might write 8 divided by 2 equals 4, for example, in algebra we never use this division symbol. Never. So how do we divide things? Well, you do it with fractions. So if you want to show 8 divided by 2, you have to write it like this. 8 divided by 2 equals 4. Now the reason we do this is because the division symbol, the traditional one that gets used when we tend to mess around with numbers, can be a little bit confusing. Let me give you an example. So if we started with, let's have 24 divided by 4 times 2. Now, if I work this out, I might have, if I did 24 divided by 4, I'm going to get 6, and then times it by 2, that gives me 12. Or if I worked out the 4 times 2, which gives me 8, and then did 24 divided by the 8, I'm going to get 3. So you're going to get different answers depending on which way you work it out. Now we sort of talked about that in Bodmas, and in theory you can work out the correct orders to do these things in. But when you look at this, you always have to think, oh hang on, which way am I supposed to do this? Do I do this bit first or do I do this bit first? In algebra you never have that problem. And the reason is because we always would write division with a fraction. So either you're saying it's 24 divided by 4 and then times that by 2, or you're saying it's 24 divided by 4 times 2. So in this one it's clear, you work out the fraction and then times it by 2, but in this one you can see the 4 times 2 is on the bottom of the fraction. So you have to work out what that is before you can then divide the numbers to figure out what the fraction is. So there's never any confusion when you use the fraction sign, and that's why we prefer it, and that's why we don't use this, and we always use fractions for division. Because in theory, although you could work it out, it just slows you down. Whereas that's very clear immediately. There's no, as I say, ambiguity about what it could possibly mean. So that's the first thing you've got to bear in mind with Bodmas. We never use division or the divide sign, we always do it with fractions. Okay, now bearing that in mind, I want to talk about the 4 operations. So you're dividing, multiplying, addition and subtracting. And I want to give you a way of thinking about it that will just help you later on when you're doing other things with algebra, messing around with the terms. So if we have adding and subtracting over here, so let's imagine we've got A plus B, or possibly you might have A minus B. Now again, remember, these letters are just numbers. If A turned out to be 5, and B turned out to be 3, then 5 plus 3 will give you 8. So this thing would be 8. Again, if it was 5 and 3, then this thing would be 2. 5 minus 3 will give you 2. But we don't know what A and B are. They're unknown to us. Alternatively, we could multiply them. So you could have A times B. And again, remember, if you want to indicate multiplication in algebra, you just write the two things next to each other. That means A times B. Or you could indicate A divided by B. And remember, we're going to do this with fractions. So A divided by B. So that's the way you write the 4 operations. The reason I'm spreading out like this is because I want you to draw your attention to these two. Each of these things is what we call a term in algebra, and that definition is quite important. Whenever you multiply or divide things together, that whole blob of stuff is called a term. Anytime you've got adding or subtracting, that separates the terms. So let me give you a couple of examples, but the important thing to realize is you need to spot your adding and subtracting signs wherever you see them, because they're going to kind of separate things out. Whereas these things you can treat as one blob, as it were. They all stick together. So let me show you. Let me give you a bit of a crazy example to start with. So if we have 2x minus 5x squared plus 3x plus 52 on the top of a massive fraction, and on the bottom of the fraction we'll have 2 times the square root of x minus 50. What is it? It looks like a mess. Horrible to deal with. But the way you should look at this, when you see this kind of thing, the important things to bear in mind are, where are the adding and subtracting signs? Because they separate the terms. So 2x, if we just look at this bit, x is some unknown number, and we're multiplying it by 2. We've got 2 lots of whatever that number is. But as I say, the important thing here is that that 2x is one term. You treat it as one kind of thing. It's an x kind of thing. This term here, though, the minus 5x squared, this is a different term here. It's separated from this by the minus sign, and from the other things by the plus sign here. So this is 5 lots of whatever x squared is, and this is going to be different from this. Yeah, so if x turned out to be 3, x squared would turn out to be 3 squared, which is 9. So this is 2 lots of 3, where this is 5 lots of 9. So they're different things. This, however, is an x thing. It's 3 lots of whatever number x was. So this is the same kind of term as this one. But they're still separate terms. You've got one term here, another term here, another term here, and then you've got a number term on the end. This is a square root term, and this is another number term. Don't worry about what you do with this or how you work it out. It doesn't really matter. The important point I want you to realize here is that each of these things are terms, and they're separated by plus and minus signs, if you like, the adding and subtracting. So if things are multiplied together, then that's one term. Again, if you've got things that have been divided, if we throw a couple of fractions into the mix, if we had 2x over 3 minus 4/3 plus 5x squared, then you've got 1, 2, 3 different terms here. As I say, these separate the terms. These two terms are fractions. This is a number fraction. This is an x kind of fraction. And this is an x squared term. It's not a fraction. But each of these things are separate. Just try and get that in your head, and it'll make a lot of other things easier. All right. Last thing then. So, we don't use division. We use fractions instead. And if you separate the things out according to terms, the reason this is important is because when you collect things, you can only collect the same kind of things together. Now, I'm going to do this in detail in another video, but the point is that if you've got 2 lots of x and minus 5 lots of x squared, and then later on you add 3 lots of x, you're allowed to combine the terms that are the same kind of thing. So you can combine the 2x with the 3x because they're both types of x. But you can't combine them with the x squared because that's a different kind of term. So you treat the terms as separate, but then you have to identify what kind of term it is. Yeah, this is an x term, this is an x term, but this is an x squared term. And we can do things with the ones that match. Don't worry about what you do with them. I'll do that in the next video. But the point is that that's why we want to keep them separate in our head, because you can combine these together, whereas you can't combine them with that one. Now, I'll be covering all of this in a lot more detail over the next few videos, but I just want you to get these concepts straight to start with.